Good morning. My name is Travis Newhouse. I'm the Chief Architect for AppFormix. I'm going to run through several live demos for you demonstrating different aspects of the product. But before I do that, I first want to kind of show you what's going on under the hood a little bit, give you a brief overview of the architecture so that you kind of know what's going on behind the flashy dashboard. The AppFormix architecture kind of has three main components. If you look at the middle there, what we call the AppFormix platform is a central piece that's responsible for all of the monitoring policy management. This exposes a REST-based API by which we accept and import the data model. We have also running on that platform adapters to different other platforms like Kubernetes, OpenStack, AWS, Azure, where we will auto-discover everything about the environment and keep that continuous discovery up to date. So the platform is aware of the data model of what's going on and is responsible for that data model. And then the REST API is how you configure policy, so the alarms you want to look at, how you want to access data, is all exposed by that platform. And as you configure the policy, the analysis is really happening at the edge, as close to the edge as possible. So we have a couple different modes, but the agent component is what provides a distributed analysis of all the metrics. In some modes, the agent's going to run on the host. In other modes where it's not possible to run it there at the edge, it'll run off the device in like what we call an agentless mode and get telemetry remotely. As it's analyzing that data, so the policy comes in over the REST API, and then as it's analyzing the data, the agents are going to generate these insights coming forward. The benefit here is that the agent can process a lot more data and shrink down that stream. So you're not flooding a central, like the central platform, with raw telemetry data that will not scale as you're going up to like thousands of devices, thousands of virtual machines. But the agent can be looking for the needles in the haystack. As it detects them, it sends that information forward to the platform. And then the platform will store that, as well as send those events to external systems to drive the automation.
How much extra load does that generate on the host?
Actually, not much. So in fact, we've measured that it takes more time and effort to create a packet, package the data, and actually ship it across a connection than it does to perform the in-memory analysis. So those events that, once they're at the platform, can be published to external systems, and that's how we close the loop. So it can go out to ITSM systems like ServiceNow, PagerDuty, or things like Slack if you're doing kind of chat ops, and then also integrate with orchestration, drive automation. These are the triggers that you want to have to feed that closed loop system. And then the third piece is there on the right is the dashboard. So then, there's a REST API that you can interact with if you want to build this programmatically, but there's also the user interface, which is what I'll be using for the demonstrations today. And then kind of just to touch on how we get that data, I want to kind of explain the different modes by which we collect telemetry from the agent. So as I mentioned, there is the agentless mode. This is where the agent's not running on the device. This may be a network device. It may be a legacy host. There was a question about Windows earlier. If Windows is supporting some SNMP counters or IPMI on that physical device, we can pull that telemetry remotely, and then the agent will analyze it. And then these agents can run in a horizontally scaled fashion, so we can scale up to the number of devices that we need to be pulled. But moving forward, what our users are asking for is streaming telemetry. They want push. They don't want polling of SNMP. They don't want polling of IPMI. They want things like Junos Telemetry Interface, JTI, which is pushing information off of the network device, or OpenConfig, which is a standard being developed for streaming telemetry. In cloud environments where we're running virtual machines, where we're running containers, when we put the agent all the way out to the edge, and that gives us better visibility than what you would see externally from a host. So when we're on the host, the agent's looking at hardware counters on the host, operating system performance metrics, and metrics per VM and per container, down to like process level metrics on that host, so that we can analyze everything that's going on and tell you how resources are consumed within that host, which VMs are using the most, which containers are using the most, And that agent, as it analyzes the data, it can do it very responsively. So we're looking at 1 second granularity for the time we're collecting, but we send a 1 minute summary forward, and we send instant notifications when something violates an SLA.
But you're not seeing process detail all the way into the VM or container from the host, right?
So from the container, you are, because actually at the host layer, you can see it. But in the VM, yeah, the VM's pretty much a black box, but it is built up of multiple processes typically on a host. And so we're making sure we have an analysis of all those.
So at that point, you would just stick it in the VM itself.
You couldn't do that. You can do that as well.
Can you also consume other streaming data sources? Say you've got an infrastructure that utilizes host-based SFlow for statistical information from systems and virtual systems. Is it able to consume other things such as that, or is it limited to the agent?
So that's actually a great lead into the last point I wanted to make on this slide, which is it is extensible through a plugin model. So
I did that on purpose.
I'm glad we met up before we started.
Sure.
Thank you. So it is extensible with plugins. And so we have a plugin model where we can collect additional types of metrics, and then those feed into the agent, and then they go through the exact same analysis engine.
Now, is there going to be community-based plugins as well?
I mean, that would be great. I mean, if we get to that point, that's ideal.
But not currently right now. They're just developed.
We haven't built the community around that yet, but it would be great to have.
That's cool.
Actually, just to add to that, currently the way we built this out is that you can take things like plugins that are available in the Nagios community and import them into AppFormix. The next ecosystem we'll be supporting is CollectD. So that's really what the thought process is, to take these successful ecosystems and make those plugins available in AppFormix.
So any plugin that works in those two,
That's it.
you can import.
We can import, absolutely.
That's good.
All right, so I'm going to walk through kind of 3 segments of the demo. First is around visibility and analysis, kind of showing you the types of data we get, the data model we have in the system, how you create alarms and how you create SLAs. And one use case to think about for this is kind of the NFV service assurance. A lot of network operators that are providing network functions, now virtualizing those network functions, there's a real challenge in not just operating the service itself, but operating the infrastructure that underlies the NFV infrastructure itself. So it's not just a matter of deploying a physical function anymore and knowing how to monitor that network service, but you've now got to manage the underlying infrastructure, the compute hosts, where those NFVs are going to run, the cloud management platform, let's say it's OpenStack, for example, managing those compute resources, and the SDN, you want to manage and monitor the control planes as well as the physical infrastructure and the virtual machines, so that when there is a problem in a service, you have to not only look at the service itself, but you have to start looking at, okay, well, was the VM performing properly? Was the host performing properly? And you want to have visibility at all these different layers. You want that real-time visibility. You also want to have analysis that shows you performance over time, so you can do capacity planning. When you're trying to spin up a new service, you want to know how many resources do I have remaining in my cloud to deploy this new service going forward, right? And how am I consuming that cloud presently? Am I doing it efficiently and getting the maximum ROI on that infrastructure that I've invested in? If I've over-provisioned my virtual machines and they're using 25% CPU, then I'm wasting resources that I could be putting to other uses. So let me jump to demo now, and then I'll come back to the alarms in a minute as we go into this. So, oh, that didn't switch right. I'll be jumping back and forth here between the demo and the slides and keep this going. This is the front screen when you log into AppFormix. Just going to refresh to make sure it doesn't time me out. And we're highlighting really everything meeting the SLA or not. So we're looking at services, like control plane services that help manage the infrastructure, things like Contrail, things like OpenStack. Ceph for software-defined storage, or Scale IO. Then you have your physical infrastructure, which are hosts, and your virtual infrastructure, which are the virtual machines, virtual networks, and they're organized into projects, that group these virtual machines by users and by roles. And these SLAs are really highlighting anything that needs your attention. You can see a couple of these virtual machines are marked at risk. You can see why. The reasons down here, it gives you like memory usage above 90% on these two hosts. And then I can navigate down and look at what's going on in more detail. So here I'm seeing all the details about this virtual machine, where it's running, what size was it created with, in terms of its CPU and memory and disk, the host on which it's running, and I can navigate either into details about the virtual machine, looking at the performance metrics in one VM in isolation, or I can go across different layers. I can look at the virtual side of things or the physical side. So if I look at the virtual side, I can click on the project that owns this VM. I can see all the other VMs that are running in this project, the quota that this project has to allocate resources. And then if I can even get a stream of metrics from all the VMs in this project and see how this is performing relative to the other things that I also own. I can look at, there's quite a few, there's 41 virtual machines inside this project. There's quite a few to display, but I can sort this by what I'm interested in. If I want to know, which one's using the most disk usage, I can sort that list there by that metric. It's going to update my charts, and I can look at any four metrics I want to see here: memory, disk I/O, network I/O, CPU usage happening inside the virtual machine. Now, importantly, I haven't installed any software inside this virtual machine and modified it. That agent collecting this information from running on the hypervisor without any modifications to the application workload or the VM.
So this is obviously tapped into OpenStack projects. Is that automatically integrated?
This is an OpenStack environment, and we have what we call an OpenStack adapter that auto discovers everything. Okay. Yeah. So when you deploy, you provide us credentials to that OpenStack environment, and we go automatically learn and continuously learn over time as things change.
Something disappears.
Yep.
Does it get rid of it after it disappears, or does it maintain it for history?
It stops showing it on the dashboard, but the history is still there, like in the API, if you wanted to see it.
Okay.
Now, as I was showing kind of earlier, if I want, I can jump, to the host as well. So if I want to go to the physical side of things, if I'm trying to understand what's happening at the infrastructure layer, now I'm looking at the host view. There's a number of virtual machines running on it. They all could belong to different projects, but I can view host level visibility now. So here, what I'm seeing is the actual amount of consumption, not what's consumed inside the VM, but how much of the host resources this virtual machine is using. All right, so I know which VM is maybe maxing out this host or over-consuming, causing disruption. And I can see a number of metrics, as I mentioned, from the operating system level, like I/O wait time, normalized load, swap usage, page rate, and then physical counters from the hardware, things like disk response time, disk latency, disk throughput, network I/O, packet rate, drop rate, bit rate. All that information at the host layer is available and shows me what's happening across my entire infrastructure. Now, that was I drilled down into a VM, went across the virtualization to the project and host. The other important thing is looking at the services that you're running as well. So you don't just want to monitor the infrastructure, but you want to monitor the control plane. For that, in this case, it's an OpenStack environment. I've got information about the core services that power OpenStack, the APIs that are there, whether it's up or down. So you can see that like Neutron is the SDN controller in OpenStack, and it's got a number of different components that make it up. We're checking the health of those components. We have the history of that over time. We're checking to see if they're up. We're also looking at the API response rate down here, seeing if the API calls are failing and giving you like who are the top listeners or top clients, of those APIs. So you can manage health of these resources.
Do you have a demo on like Kubernetes?
Today I didn't prepare that.
Okay.
But
so can you do like auto scaling and stuff like that from detecting?
And I'll show an auto scaling with using heat in
Okay.
a little bit later.
Okay,
Yeah,
which is,
and it's a very similar concept.
Okay.
What I want to also show about kind of now on the visibility side is that beyond just the real-time metrics and showing kind of service health, how VMs or hosts are consuming resources, there's a second aspect beyond real time that we want visibility and analysis of how things perform over time. And for that, we have a number of tools, for example, capacity planning, where this is where you want to understand what resources are being consumed and what's available. So here we're seeing resource allocation, how many across this cloud environment, how many virtual vCPUs, how much disk, how much of my memory have I allocated, how much is still available to me. You can see that there is oversubscription, on the CPU quite heavily here. It provides me, what seems to be a lot of resources just in case those VMs are not totally consuming what they've been provisioned. You can see that capacity over time. Yeah.
Question. So you've got a whole lot of data here that you can do stuff with. Can you expand a little bit on like once you have all this data, right? You got your trending analysis and all of those things, and what other things do you do with the collected data? Like, for example, you've got say your vCPUs that allocated at this percent, and this is available. Can you do triggered scaling or any other automated process?
Yeah, I'm going to touch on that in a moment. I kind of wanted to give an overview of just sort of what we do, what we have with the data. So yeah, no, that's okay. I'll speed up on that. I'll speed up on that. So let me quickly. I'll give you one example here on a report. So if I look at this report, one thing we do, reporting is a way to analyze the data over time. So I can generate a report for any time period, see how things are consuming over that range of time. But what you'll see here is we're giving you right sizing recommendations. So we're looking at those VMs. We're saying, okay, this VM is only consuming this much of its provisioned resources, right? Mm-hmm. Over this period of time, we think that, we'll recommend, why don't you change the flavor down, make it smaller, or maybe raise it up because it's maxing out and maybe it could use additional capacity than what it has. Okay. So that's one of the kind of analysis that we're providing for you to maximize kind of ROI on how you're consuming the cloud. Okay. The next thing I'll jump to kind of is the alarms. And
actually, just real quick, sorry to interrupt again. So it's doing all of this analysis and then it's making its recommendations. Can you expand a little bit on how that works on the back end? Is that part of your machine learning algorithm suite? Is that, is it actually using that data in an unsupervised manner over time?
Yeah, so what it is like, as Samit mentioned, as we get data coming in, right? So the agent's looking at real-time data and analyzing it, but it's also providing summaries coming forward. And as we ingest that data, we put it on a bus. We store it in the database so you have the history. It streams out to like listeners on the dashboard, and then it streams to different modules that we built, different analysis modules. Okay. So one of those modules is this right sizing, right? Like it's saying, okay, I want to summarize this data. I want to look at it over this period of time and say, okay, analyze it and see where things are not consuming or where they're out of band. Like it's saying, okay, this 25% of what has been provisioned, and that's a module we've built. There's ways that you can subscribe to streams of data to build additional modules, and then we continue to add analysis as we grow the product.
So you could, in theory, take some of that stream data and feed it into an existing analytics system that might have your own machine learning bits on the back end if you want to.
Yes.
And subscribe to specific pieces of that stream or series of streams. Okay, cool.
Okay, so one additional aspect I do want to show before I jump into the alarm is what we call an aggregate. And this is actually a really powerful and important part because I skipped over it a minute ago when I talked about hosts, projects we learned from OpenStack. But aggregates are a way to tag and group things in the system. And the reason this is important is that you may want to apply policy. And when I configure an alarm, what I'm doing is I'm applying a policy to how to monitor a set of objects in the environment. So here I've got an aggregate called test1. There's 2 virtual machines in it. I can have an aggregate of hosts. I can have an aggregate of network devices. I can have an aggregate of virtual machines. I can even have mixed aggregates that say, okay, this virtual machine plus this host and things I want to monitor with this set of rules. And so as I go to the alarms, what you'll see is first, I'm going to kind of show you a dynamic alarm that's there and been running. This is like one that we've done machine learning on. So you can see here, the blue represents the mean that we've learned. Now this alarm was created in a manner where we're giving hour by hour baseline. So, and for 1 week. So you as a user select the training period. You can say, I want a 1 week. It's gonna be a rolling 1 week period. And it's gonna give you hour by hour baselines. So the blue is a mean for each hour of the day for the last 7 days. The purple and the green are kind of the deviation above and below that, which is kind of the expected band of operation for this metric, which is CPU utilization, right, on the host. And you can apply that to network devices for any metric in the system. You can create one of these alarms with a adaptive threshold, and it's going to learn it. And then the agent's going to be evaluating the data that's been learned, right? So as it sees anything out of this range, it's going to send that notification forward.
So the Contrail stuff we saw yesterday, the network intent-based security,
Yeah.
does that integrate with this? Do the two talk together and correlate? And
I don't.
as far as like views and stuff like that?
So
and
right now we're working to bring those together, actually. Yeah. So the Contrail Analytics and AppFormix are both we're in the process of putting those
over
together.
time they will.
Yes.
Okay.
Yeah.
I have just a question regarding this. Is this a method where you group things together that have dependency? I don't know, this NFV is dependent on this router and it's depending on this uplink. So this can you group together and say, okay, all over, then one service is interrupted when one of these components is failing? Is this kind of the idea?
So the grouping there, not like we don't have the root cause analysis, if that's what you're thinking of in terms of the dependency map. That's something we're building on top of the AppFormix platform. So there's something that's called HealthBot, AppFormix HealthBot, and it's taking the data model that AppFormix has, the telemetry that it provides as a platform, and building that root cause analysis on top that says, okay, I know that this host or this virtual machine on this host is sending traffic through this virtual network, which traverses this network path and linking that root cause together.
Okay.
And that'll eventually talk to the analytics, the security model from the network
Right,
as well,
right.
for intent-based.
And that's a natural evolution,
Yeah.
because we're talking about, generally speaking, unlabeled data in network, data inside the network. So you use things like clustering and stuff to identify those relationships that over time you can start making those connections, those relevant connections. So it seems like a natural evolution where you sort of have to go next, to differentiate the platform from other people using ML right now.
Okay, so I want to keep time check here. So what I'm going to do now is go to some of these use cases that you were asking about, kind of closing the loop, right? So kind of showing you the building blocks. We've got the telemetry, we've got alarms. Alarms actually make up what a building block for what we call a policy, an SLA policy. So you can have a health policy, a risk policy, a scheduling policy. These are going to affect different aspects. So when you see a host at risk, you'll get a notification. So these are multidimensional, or I can have a policy for virtual machines, or I can have it for these aggregates. So if I want a policy for a given aggregate in the system, then I can perfect time. I can apply a policy to that subset of resources. Now, with the scheduling policy, what happens is if the host is at risk, we have a plugin for the OpenStack scheduler, we have a plugin for the Kubernetes scheduler that's going to check if the host is eligible for scheduling or not based on your definition of what it means for a host to be meeting its resource management SLA. What I'm going to do also now is show the heat. So heat is a service orchestration tool. I'm going to create a heat stack here. It's going to spin up a number of virtual machines. Stack's getting created here. We'll take a moment for it to get created. While I do that, let me just log into this box. Now, we learned that when you create a heat template, it's a number of virtual machines that you're putting inside there. And we actually learn that from heat and create a tag and create an aggregate in AppFormix to group all the virtual machines that belong to that. So what I've done in this example is it's spinning up virtual machines. The heat template is. And we have a plugin for heat that you can define your AppFormix alarms inside the heat template. So when you deploy your service, you're also deploying the configuration necessary for how you want to monitor that service. And then heat as a feature called auto scaling, where when an alarm triggers, you can tell heat, I want you to scale up a resource. So I want to have multiple replicas. And that's what I have here. So when this heat started out, it has a replica set that allows up to a maximum of 3 virtual machines. When the virtual machine spins up, it's actually driving a lot of load. And you can see part of the heat template there is alarms that have been created, CPU alarm for high, CPU alarm for low. So these rules were programmed by the heat template to monitor the VMs that it deploys as part of this service. And then those alarms will notify back to heat, and then heat can react to it by scaling up or scaling down. So if we see the CPU go high, heat's going to scale that. And if we see the CPU go low, it's going to scale it down. So actually there, the alarm just triggered. So we see the reason why it happened, which virtual machine was affected, the value that was sampled. Here we're seeing CPU is 100%. I can click on that virtual machine and go see on the graph. In fact, the virtual machine is so new that we haven't even gotten the first minute of data. There finally just popped up there. But we already do see the alarm popping up on the chart, pushed by the agent the moment it saw it, which was looking at, in this case, average CPU over 30 seconds. And then if I go back to this aggregate, you're seeing that heat's already spun up another copy of this virtual machine and will continue to do so up to 3 because that's how the template's been defined. So now you're taking the power of AppFormix to have this very fine granularity of visibility and report and analytics, and it's feeding that signal back to heat, which is your service orchestrator that can react to those insights that AppFormix is providing. So as it continues to go there, it's going to spin up. It's going to stop at 3, and then if I stop the load, it'll start bringing that back down.
I have just one question. With this more and more dynamics environment where things are spun up and tiered down depending on the load, do you also gathering statistics about how many machines were there and have been created and tiered down again?
Like the number of virtual machines.
Yes.
Yeah, we have like cluster level, like for an entire cloud, like how many projects are there, how many virtual machines, and we know that trend over time, and we know that along with that capacity planning data that I showed briefly. So you see kind of like what's available plus what's consumed over time.
So you see, for example, this has triggered 500 times an alarm, and then additional machines were created and so on, and you have a trending, let's say, and reporting on what's going on. Yeah?
Right.
Okay, good.
Okay, so I do want to also now kind of give some focus to the network side as well. So kind of looking at in the network, what we have is we have topology view for your network devices. This is kind of the physical view of the system. You have a number of routers here connected to a number of hosts that may or may not be running virtual machines or containers on them. And in this demo, what I'm going to show you is kind of, again, closing that loop, but even on the network side as well. And so I'm going to be sending traffic from these hosts through this router. But just to kind of quickly show you, this is a heat map. So you can select, a number of any kind of resources you're interested in. If I want to look at, metrics coming from SNMP, and I want to look at, the amount of egress traffic coming on each interface. It's going to highlight that. It's going to auto range. AppFormix has created this range here based on what it's observing, and highlighted then how these different devices fit into those ranges, give you a visual kind of heat map of what's going on. You can look at host, you can look at virtual machine as well. Now I'm going to start up some traffic here, and let's see.
Well, while you're starting that up, just to be a little bit transparent, we're familiar with dashboards that give us some visibility, and we understand that visibility is important. I think there's a growing interest in how you are gathering, interpreting the data, making predictions, things like that. It's kind of an important part, I think, to us. Like we've seen a lot of dashboards,
Yeah,
and it's fine. It's really slick,
Sure.
and we get it.
Yeah.
But what can we do with it that's different than some other platform? That's cool. Like, how are you getting this data? How what models are you using? What are you doing to figure out or to make, like you said, those predictive analyses, because there's a lot of people throwing around the ML buzzword right now, and it's almost it's like eye roll city for me at least, right? But then when I start seeing somebody say, no, this is how we really do make predictions of your network and how it's practical, that makes me sit up in my seat a little bit, you know?
Okay.
So just throwing it out there.
Sure. No, I mean, I can delve deeper into that for feedback, and we can talk through that. So, I mean, why don't I look at an alarm maybe in more detail and kind of show you a little bit of how that's defined. So, there's certain classes of things where the ML is maybe not necessary. Like sometimes you just want to know an absolute number, right? And so you have that ability at AppFormix to say, I want an absolute threshold. Like I don't want to see drops. But if you want the dynamic, then you select that you want a dynamic rule. Again, it's a policy, so how it applies is going to, even as the infrastructure evolves, this rule will continue to apply to different things that come and go in the system. You select any of the metrics that you're looking for. So here, let's say I want to look at network devices. And I've got metrics coming from SNMP, or I have metrics coming from JTI. I could look at, the number of queue drops coming in on an ingress interface, and I want to look at that over a period of time. So now we have the power to say, okay, what interval do I want to look at that at? So it's a 60-second interval or down to 1 second. So if I want to say a 10-second interval at the queue drops on an interface, I can look at the max, the average, the sum. I can define how I want to collate that data. So there's going to be lots of data points coming in. Do I want to take the average? Do I want to take the max, the min over that period of time? And then the dynamic threshold allows me to say, okay, we have two modes that we can choose for the algorithm. One I described earlier was the k-means, where we're giving you hour by hour clustering. So we're saying, okay, take that hour's worth of data across all the objects in the system. Use the clustering to find out what is the baseline across those objects for that period of time. And then we're going to repeat that each hour as new data comes in and record it for each hour up to the duration you've asked for. So if you just want to know it for 1 day, we'll keep 24 hourly baselines. If you want to know it for the last 7 days, we'll keep 7 by 24 hourly baselines. And we'll keep updating that as time goes on across the set of objects that this rule applies to. So you could have this rule apply to, the objects that are powering, a whole row in a data center. Maybe it's all the top of rack switches plus, the router going up. And you want to monitor that set in that group in one way. And so you can apply rules to that group and apply another rule to another group in case they're performing differently.
Travis, does that learning period get affected when maybe an outage affects the real metric that this is being measured against? So if there's a widespread outage that kind of throws the whole learning process off, is that counted in or just skipped over?
I mean, that's counted in. You'll see that. I mean, the benefit of having that continuous learning, right, is that you'll see that period. Maybe if the outage was an hour, let's say, it would affect that hour baseline for the next week, let's say, at that time of day. So Tuesday at 3 o'clock, you're going to see that spike maybe affecting your baseline for the next week or so.
That's going to consider that a deviation from the baseline, right? It's not going to care that it's an actual outage. It's going to say this is something that's different that happened last Friday. So it's going to consider that to be a. Right?
Yeah, I mean, it depends on the outage scope, right? So if every device happened to see it, that's going to affect the baseline up that you recorded during that period of time. If it's one device, that's not going to be enough to skew the cluster, but it's going to be enough to trigger the alarm, right? So there's two parts to it. There's what you're learning and what baseline you're going to have going forward. And then there's what you're kind of analyzing currently with the known baseline that you have. So you have a certain baseline, you have an outage, something spikes up or below what you expect. That one device is not enough to skew the baseline going forward, but it's enough to trigger that you have a problem and that you need that notification to come forward and alert you.
And if you're doing maintenance or something, can you say?
Yeah, you can turn these alarms on and off. So again, you can say right here, I can turn this alarm off or turn it on, right? So, and that's, again, if I've got an alarm applying to a certain group, I can turn it off just for that group that I'm doing maintenance on.
From the ML perspective, when you do maintenance, will it in my understanding, it will always continue to be learning what's going on. So it might over time learn that, the third Saturday at 4 a.m. is a maintenance period. So if I see a deviation from what was originally considered the baseline, 3 months in a row, that becomes the new normal.
Yes. Yeah. I mean, so if you do have a regular maintenance interval, that would be incorporated into the baseline, of course. So then you wouldn't see alarms when it goes off. It's like expected,
Right. So
right?
it just continues to learn over time. Hence the name machine learning.
Well, we'd love it if everything was so perfect and static and great, wonderfully designed, where you didn't need to do anything and everything. That's just not.
I'm not seeing machine learning, I'm seeing statistical regression,
Yeah.
linear algebra. But
Well, I mean, that's a part of it, but that's what, a lot of people are using the term machine learning to talk about advanced data analysis. You're right.
So there are two kinds.
there is a
there's
difference.
obviously, as
They're
we
related.
mentioned, there's supervised and unsupervised learning, right?
Yeah,
so
that's
this
right.
stuff is the unsupervised learning,
Yeah.
right? And that's the kind of stuff that you can put in and the system's going to figure it out yourself. The supervised requires obviously some kind of training set, right?
Yep.
Which is usually going to be a person, and it's going to learn from the actions you take. And that's where some of the intent model comes, especially where
That'll be
the
on the
Project
road.
Yoda that Samit showed is like, it can learn what action did you take and start suggesting that action going forward, right? So it's learning the behavior, not just the data.
yeah, and that's where we're headed. We're not there yet. We're long way. So it's still unsupervised learning or linear regression, statistical analysis.
Well, semi-supervised learning, because you're using unsupervised learning to create tags, which turns it into a supervised learning experience. But ultimately, yeah, it's advanced statistical analysis, which is fine, right? It's just, what do you do with it now?